Have you ever wondered where does all the electricity you use come from? How is so much electricity produced to power thousands of homes? This video will answer your questions. What are power plants? Power plants are defined as a whole system that produces energy in the form of electricity from primary energy that comes from the fuel. Most of them are thermal power plants that use a generator that converts mechanical energy to electrical energy, and it is how the fuel that produces primary energy, that's heat, gets converted to electricity, using the mechanical energy coming from the heated up steam. The generators are mainly turbines that produce the electricity. These things mostly provide a big ton of energy, as one generic power plant dependent on the fuel it uses may have enough energy to power a whole city, but because some are that advanced, they also need a ton of engineering and are expensive to build and can cost a lot on crashes or meltdowns and even cause harm. How do turbines work? The question here is how turbines convert mechanical energy to electricity. There is something that pushes the turbines to rotate. For thermal reactors, combustion gases or steam is used to push the turbine, while for hydroelectric power plants, water is used as a moving fluid to turn the turbines. To go deeper into it, the blades of the turbine are rotated, and conversion happens in the center as the rotating elements are surrounded by a large magnet and coils of copper wire. Copper wire doesn't have magnetic properties, but actually does interact with magnets because it has electrons loosely held, and the biggest characteristic of metals is having loose electrons, which makes them a conductor, and the one lose electrons and become positive ions in ionic chemical bonds. So moving a magnet around copper pushes the loose electrons and creates an electrical current. The reason why copper is the best option here is because copper has the best interactions with moving magnets, which means it is the most diamagnetic metal to use here. There should be a force to spin the turbine. How does gas act here? A heated gas or air itself becomes a lot lighter and hence gains lifting properties because it is surrounded with a heavier gas that's air. The way it works is that, when you heat up something like water, you heat it up until it's steam. Steam is light because it is much less dense and hence it gets displaced by the surrounding air, which is how it moves up as the air keeps building below it. It is also how a helium or hydrogen balloon floats. In the same way, the lighter gas uses its lifting properties to get the turbine's blades to be pushed up to turn. This experiment can also be done at home, where you create a light paper turbine, and then light a candle beneath the blades. The candle with the high temperature would heat up the air, and that warm air with low pressure would move up, turning the turbines. Different types of power plants. There are nuclear power plants, hydroelectric power plants, coal-fired power plants, diesel-fired power plants, gas-fired power plants, geothermal power plants, solar power plants, and wind power plants. Starting with nuclear power plants. These power plants use nuclear chain reactions from which heat energy is released. That's why they are thermal power plants. They are the most powerful power plants, yet the most eco-friendly and safe nowadays. Even though some meltdowns are capable of causing a disaster, they are too rare to happen, and over time, they become much less likely to go wrong. I also encourage communities to use them instead. You may have heard about nuclear fission, which is the energy production process in nuclear reactors. This process involves the splitting of a heavy nucleus, like uranium-235, or a fuel plan for future use, that is thorium-232. They are fissile because when a neutron hits them, they can split. Even though these isotopes are weakly radioactive, they are still heavy enough to undergo fission. The fuel used is a pellet of uranium dioxide. Usually, 5% of the uranium in the oxides is the fissile uranium-235. Neutrons at a particular energy will be able to trigger uranium-235 nuclei to split. Also, after a neutron hits one nucleus, along with a loss of energy, it also releases 3 neutrons that trigger other fissile nuclei, which is called a chain reaction. But when enriched uranium containing 5% U-235 loses enough fissile isotopes, it will be considered depleted uranium. The reason why they use uranium dioxide is that it has a higher melting point, and hence the hot fuel won't melt. Coming to where the initial neutrons come from in a reactor, what happens is that they are released from the fission of californium-252, which is so heavy that it undergoes spontaneous fission radioactive decay 3% of the time. The neutrons released from it hit a moderator to slow down, and hence they are more likely to hit uranium-235 nuclei. There can also be more ways of doing it. The fission process is so fast that it takes nanoseconds to split many nuclei. Nuclear reactors work exactly like how nuclear bombs work. And if you are wondering, why haven't reactors exploded yet? The reason is control rods. Control rods are what absorb excess neutrons and keep the energy production controlled. They are the ones that prevent your fuel from being a nuclear bomb. People usually use slightly heavy elements like some of the lanthanides and onwards. The nuclear power plant has many advantages, like being one of the safest plants, and emitting no greenhouse gases. Just steam, and also produces a massive amount of energy. But when a uranium-238 nucleus absorbs a neutron, it eventually turns into plutonium-239, which is fissile, but too toxic to use, so it's just disposed in waste, and it also makes it a lot more toxic. People hate nuclear power because of radioactivity. They consider this a risk of nuclear disasters, as places like Chernobyl and Fukushima have been abandoned decades ago. They think workers in a reactor are exposed to harmful radiation, but actually, the access to different areas is controlled, and they only receive a beneficial dose. Although it is the best power plant, it is the most expensive one. Coming to coal-fired power plants. They work by burning coal as fuel and also produce a lot of energy, but they aren't worth it because of the disadvantages they have. But they are used everywhere because of a cheap cost to build and run. People do want to switch to a less environment impactful system. What it does is that it releases greenhouse gases that are mainly carbon dioxide produced by the combustion of coal. Almost all the coal is made of just carbon. It is flammable, releasing a lot of heat, but another byproduct is carbon dioxide, which is the byproduct of its combustion, and it is a harmful gas released. If we take its contributing percentage to the pollution in air and then multiply that by how many people die annually because of air pollution, we can get how many people are killed just because of these power plants. This is why they are not an ideal option. Something much better is hydroelectric power plants. They are not thermal power plants, hence, they are more simple than other power plants. They use the flow of water to turn the turbines, and that's how they produce electricity. They also produce a lot of energy, almost more than a nuclear power plant, because of a very high speed flow of water. You can also call them eco-friendly as they produce way less greenhouse gases than burning coal or fossil fuels. The biggest disadvantage is that you would find using these is that they can't be placed just anywhere because they need a continuous supply of water like rivers. They also occupy a lot of land at the same time, and another thing is that all the water decomposes the submerged plants into greenhouse gases like methane. But still, they are a pretty good option, as they are affordable and cost-effective. Now the diesel-fired power plants. Diesel-fired power plants are very different from dedicated power plants as they don't produce enough energy alone, so they are only used as a backup. But at the same time, they are also very cost-efficient. They can also be built easily and require a small area. The disadvantages are that these cost high for maintenance. The fuel is too expensive to use, which is why they use less. Also, because they are burning hydrocarbons, pollution is released. Gas-fired power plants. Just like the last two power plants, gas is combusted here. They are fossil fuels, but the emission of greenhouse gases is relatively low. Methane is the least expensive gas that is used here. Advantages are that it is very cost-effective and produces good amount of energy, but the drawbacks are that it pollutes the air, and if in case the power plant breaks, the harmful methane gas is out. They also can be produced so much energy. Wind power plants. These are what you call windmills, and they are placed in areas where there are high probabilities of strong winds occurring. The winds directly turn the windmills, so they are the simplest design. The turbines, which would can all wings, are tilted usually, so they get forced to turn in strong winds. One wind turbine produces 3 MWh per day, which may sound too low, but a wind farm contains hundreds to thousands, which would produce enough energy to power a whole city. Because it's so cost-effective to build and run, it is one of the fastest growing energy productions for now. Running it requires no fuel, now a lot of maintenance. Not it's going to cost you any destruction of the environment at all. But while building it, what you will need is, like many other power plants, is an environment where you have a frequent strong supply of wind. Many power plants require a lot of geography for where to build like these ones. And finding areas with strong supplies of wind is also hard. Also, in case there is a storm and a wind gets too strong, all that friction and kinetic energy in the turbine's core creates heat. If that heat energy gets too high, it will start damaging the windmill, causing fires, or without causing fires. Turbines can be damaged directly because of friction, but also this is very rare to happen because modern windmills are designed to handle high winds. Geothermal power plants. These power plants directly use the energy produced by the natural environments on Earth. Mainly, steam that is produced by reservoirs of hot water is used to turn the turbines. This way, it wouldn't harm the environment. But as long as the water is pumped back into reservoirs faster than it's depleted. Otherwise, this power plant doesn't require any fuel. The drawback is that it has high costs, ranging from $2 to $7 million, and also it has certain environmental requirements. But it is also quite energy efficient. Solar power plants. These power plants act on daytimes as they directly get energy from the solar power that the sun provides. Because of this, they are the most renewable and don't require any maintenance, lasting 20-25 years. There are also solar thermal plants that are cost-effective because instead of using solar panels, which directly convert the energy, giant mirrors are placed accordingly to concentrate sun's rays on a very small area to create a significant amount of heat, which produces electricity by turning the turbines. Solar power plants are the most efficient and do not produce any carbon footprint as they don't need to. They directly get their energy from the sun, but their daily output for MWh, which is very low, so what this one can be used for is as a backup in emergencies if we have to high pollution, or the dedicated power plant seems to have issues running. The good thing about this is that you can use it to get a little energy every day and store it, which you can use for a backup because neither of this requires any resources to run, nor it's harmful to us or the environment in any way. The only thing you need is high budget to build one and an open view from east or top so they have high access to solar energy. Also, the air should be clean because high concentrations of greenhouse gases absorb more solar energy. Now we have talked about different types of energy production systems that provide our daily electricity, but the best type of power plant, I think, would be nuclear power plants because they offer the highest energy, with almost no impacts on the environment. They are still very expensive to build and run, but they are worth it, because they have the capability to power many cities. But the thing is nuclear waste. It contains all the depleted uranium where there is a too low concentration of fissile uranium. What makes it more toxic is that some uranium-238 has captured neutrons and some uranium-239 and its decay products are present. It is what makes nuclear waste toxic. Still, nuclear waste production is very low and it is also sealed to block half of the radiation, and most of the radiation in it is weak. Another problem is that uranium-235 is also quite rare and hard to find. Out of all the uranium you find, 0.72% of it is uranium-235, which makes it a lot more rare. But there can be another easier way to obtain this isotope, and nuclear reactors themselves do that. Apart from finding the natural uranium-235, it can also be synthetically produced by radioactive decay of other isotopes, such as if the fertile U-238 captures a neutron, it will turn into U-239, which beta- decays into neptunium-239, and then plutonium-239, which alpha decays to U-235. As I said before that a fuel pellet is concentrated with 5% fissile uranium, we can still use a better alternative for the fuel like thorium-breeding fuel. A normal uranium reactor has a core with a bunch of fuel rods containing UO2, and it is where the chain reaction takes place. Then, there are controls rods to absorb neutrons and prevent the reaction going over the limit, and the moderator to increase the reaction by reflecting neutrons. Instead, it uses a thorium fuel system, where there is a seed and a blanket. The seed is the fissile part while the blanket does the breeding. To go in more detail, thorium-232, which is the main fertile isotope, used here captures a neutron to turn into thorium-233, and this isotope beta decays into protactinium, and then uranium-233, which is fissile. This process is called thorium breeding, and it is far better because unlike uranium-238 breeding, it takes far less time, capable of producing more fissile U-233 than how much is burned. Many countries like United States, China, India, Japan, and Russia are working on upgrading the current reactors to run on thorium fuels to produce more energy, be safer to us and the environment, and be cost-effective. The new reactor will be able to make more energy, as uranium-233 can be obtained more easily because the decay process is faster. TH-233's half-life is 22 minutes and then it decays into Pa-233. The half-life of this one is 27 days and then it results with the fissile U-233. On the other hand, U-239's half-life is 23 minutes and then NP-239 has 2 days and then Pu-239 has to alpha decay with 24,110 years to become the fissile U-235. This is what allows to produce fissile uranium without mining, and it is produced at a higher rate than burned, which is fit for a breeder reactor. It is also cost-effective and safer because thorium-232 is 3 times more abundant and 3 times less radioactive. There is also a very low rate for nuclear waste from breeder reactors. This new nuclear advancement may create a big change in the world because how powerful nuclear technology is. It will cover up many parts of scientific development someday. Thanks for watching.